All right, everyone, in this video, we're going to be taking up the practice equations quiz. So in the first question here, we've got a baseball thrown right up into the air and reaches a maximum height of 25 meters. And we want to know how long is it going to take the baseball to fall to the ground from that height. So a couple things you have to keep in mind. Here we have a situation where we've got maximum height. So when we've got maximum height, what that means is that the ball is stopped. It's at a maximum height. It temporarily stops before it begins coming back down to the ground. So it went up, it stopped, and it's going to go back down. So what we know is that the initial velocity here is going to be 0. Other things we know are that we have our acceleration. So anything in the air is going to be traveling at negative 9.81 meters per second squared. And the other thing is, when our ball's falling, it's going to be falling downwards. Keep that in mind, downwards. So your displacement has to be negative 25 meters. You're falling downwards, okay? So kind of keep that in mind. Now, our positive direction is going to be upwards throughout this whole thing. So we have all of our data. We're going to figure out the equation. We're looking for time, how long it's going to take. So we match up with eHarmony to dV hat squared equation. We're going to substitute in here. So be careful, you got the negative height, negative acceleration. You do a little bit of mathematical magic, and you end up with a time of 2.3 seconds. Okay, so that's how long it takes to fall. So classic example of falling from maximum heights. Remember, at maximum height, an object's velocity is 0. Okay, could be initial or final velocity. Okay, then we have this situation. You got a dragster. It's accelerating 24 meters per second squared while coming to a stop from 530 kilometers an hour. I wonder what's the displacement of the dragster. So we don't have a direction. We're going to put forward for the direction. Things that we have to kind of keep in mind are going to be the givens. So to be careful, one thing that's really important is this. You cannot use kilometers per hour. You have to convert that to meters per second. So we divide by 3.6. Coming to a stop, so that's my final velocity. My acceleration, wait a second, I'm coming to a stop, moving forward, it must be backwards. So classic example of negative acceleration here. And we're looking for displacement. You look around, do some formula matching, and you're going to find that it matches this one, my favorite equation. So you substitute in. Issues to be careful with here. Your V2 is 0, so be careful, you can't switch these around. Don't forget to do the square for the 147.2 meters per second. Do the square there. Do a bit of mathematical magic, and you're going to get a value of 451 meters. And that is your rounded answer, because here you have 3 significant digits, limiting right there. So that's it. Okay, next we've got an example. This is a part of a multi-part motion type problem, where what we're doing is he's driving to work, and then he comes to a stop. So he's going from 55 kilometers an hour, and then he comes to a stop. All right, so 0 meters per second. And then we have another acceleration. So you got 2 parts of motion here. So you have to really be careful. 2 completely different things. We're slowing down and then we're speeding up. So it's like doing 2 problems at once. So what we want to do, write down our givens, and the best way to do this is draw a little sketch. So you're going from 55 to 0, and that takes 4.1 seconds. So that's the first part of motion. The second part of the motion, you're going to be going from 0 to, I don't know what velocity, but you're going to be accelerating at 6.4 meters per second squared for 2.5 seconds. So you do 2 problems side by side. That's what's involved here. So on the one side here, what you want to do is you want to do my conversion, kilometers per hour to meters per second. You know your final velocity is 0. Takes 4.1 seconds. I'm looking for displacement. Formula matching gives you this formula. You substitute, you end up going 31.4 meters forward. Positive is forwards, remember. This side, we're going to be starting from rest. So remember, I'm looking at this part here. So I've stopped. So I wonder how far do I travel when I'm accelerating here? So from rest. So that's my initial velocity now. If you're accelerating at 6.4, your time is 2.5. Do the mathematical magic through the eHarmony, equation matching, a little bit of substitution here, and you end up with displacement of 20.3 meters for the second part of the motion. I want to know what's my displacement for the entire trip. All you do, you add the first part to the second part, end up with 51.7 meters. And then at the end of the day, your total displacement was 52 meters. I think it should be 52 meters over here. And that's it. So I'm going to fix that typo later on online, and that gives you an idea how to do these types of problems. Remember, use a nice systematic approach. Be careful for any kind of negative accelerations that you might have. Oops, I'll go back here a little bit here. So be careful with that. Always do those conversions. Give me your positive direction and then round right at the end. All right, that's it, folks. Take care.